Welcome class 11th. Today's lecture we are going to deal with acceleration. After dealing with speed and velocity, we are going to start new topic, acceleration. What is acceleration? Acceleration is the rate of change of velocity with time. Okay. A is given as delta V upon delta T, or rate of change of velocity with time. Okay, what is uniform acceleration or uniformly accelerated motion? This is very important because we are going to start the equations of motion after this lecture. Okay, so uniformly accelerated motion is defined as when a body changes equal amount of velocity in equal interval of time. Once again I am repeating, a body is said to possess uniformly accelerated motion if its velocity changes by equal amounts in equal interval of time. Like a very special case and very simple case I am giving you as an example. Acceleration due to gravity is 9.8 meter per second square. So first of all, let us discuss this unit, that what is this meter per second square. Okay, then only acceleration will be clear to you. मीटर पर सेकेंड स्क्वायर का मतलब क्या है? इसको हम ऐसे लिखें, मीटर पर सेकेंड, तभी तो ये लिखा मीटर पर स्क्वायर. अब ध्यान समझिए, ये कह रहा है कि मीटर पर सेकेंड. अब एक्सेलरेशन ड्यू टू ग्रेविटी की वैल्यू कितनी है? 9.8. अब देखिए इसको, पर सेकेंड जो बॉडी की वेलोसिटी है, अगर उसको फ्री फॉल के लिए छोड़ दें तो उसकी वेलोसिटी पर सेकेंड कितने से इंक्रीज करेगी? 9.8 मीटर पर सेकेंड से. मीन्स अगर फर्स्ट सेकेंड में उसकी वेलोसिटी 9.8 मीटर पर सेकेंड है तो नेक्स्ट सेकेंड में उसकी वेलोसिटी कितनी होगी? 9.8 प्लस 9.8. नेक्स्ट सेकेंड में उसकी वेलोसिटी कितनी होगी? 9.8 और ऐड कर दें. मीन्स 9.8 से हर सेकेंड में उसकी वेलोसिटी की वैल्यू में क्या होता जाएगा? इंक्रीमेंट होता जाएगा. तो यही एक्सेलरेशन का सेंस है, जिसमें हमें ये देखना है कि हर सेकेंड वेलोसिटी कैसे इंक्रीज कर रही है या डिक्रीज कर रही है. दोनों कंडीशंस हो सकती हैं. तो एक्सेलरेशन कैन बोथ बी पॉजिटिव एज वेल एज नेगेटिव. द नेगेटिव एक्सेलरेशन इज रेफर्ड टू एज रिटार्डेशन और डीएक्सेलरेशन. And positive acceleration means velocity is increasing with time, and retardation means velocity is decreasing with time. Okay, so by graph, how we can say that position time graph represents different accelerations. Okay, so let us draw a position time graph. This is position, this is time. When the graph is like this, then we say that the acceleration A is in direction of V. Okay, in this graph, when the graph is like this straight line, then we can say that acceleration is 0. This graph will be more clear to you when I will deal with equation of motion. When the graph is like this, then A is opposite to V. Just note in mind, when the graph is upwards, then acceleration is in direction of velocity, means positive acceleration. When straight line, acceleration is 0, and when the graph is downward, then it is retarding or opposite direction. Okay, velocity time graph. Velocity time graph will not be a curve. Velocity time graph will be a straight line. Okay, why this straight line and this curve? I'll tell you when I'll deal with equation of motion. Okay, now two more terms, average acceleration and instantaneous acceleration. Just like in velocity we are having average acceleration and average velocity and instantaneous velocity, here also we are having average acceleration and instantaneous acceleration. Average acceleration is for a time period, and when we put a limit delta t tends to 0 for the same average acceleration, it becomes what? Instantaneous acceleration. So let us define it by the equation. This delta V upon delta T is what? This is A average. And when we put limit delta V by delta T and limit delta T tends to 0, then this A becomes what? Instantaneous. This is become dV by dt. Means the acceleration at a particular second or particular time, where this time interval tends to 0. So to calculate average acceleration from the graph, we will take what? We will take 2 points on the graph like this and the corresponding values for velocity time graph. And to calculate instantaneous acceleration, we will calculate what? Slope of the graph, or at a particular time what is the velocity. This is the acceleration which is we are taking for instantaneous time. Okay, the slope will give you what? Instantaneous acceleration, limiting delta t tends to 0. So again I am defining the instantaneous acceleration at a point is thus equal to slope of the tangent to the velocity time graph at a point. Okay, and average acceleration during any time interval is thus equal to the slope of the velocity time graph corresponding to the time interval, not of the tangent. टेंजेंट का जो स्लोप होगा वो इंस्टेंटेनियस एक्सेलरेशन देगा, और जो ग्राफ का स्लोप है वो क्या देगा? एवरेज एक्सेलरेशन देगा. ठीक है. In next lecture we will deal with equations of motion. We will derive it and find that why these graphs are straight line or why these graphs are curve. Okay, this all will be clear to you. Thank you class.